Welcome everyone. Welcome to today's lecture. On today's lecture, we are going to go into PROTA structure and see on how to increase the size of a structural member, and then without the analysis being expired in PROTA structure. So many of you are having are facing such kind of difficulties in a PROTA structure when you run an analysis on on structural members or on a building, and you find that some structural members are not okay, or the design it is not valid for such structural member, then you will try to increase the thickness of the member. And when you are increasing the thickness of the member, you will find it difficult for the analysis will not expire. So there are so many ways of doing such in order to increase the thickness of the member without the analysis being expired. So we just see under our management of S.A. Design Consult. So let us create a lecture on such in order to highlight you much more on how to do such kind of things. So I have an existing project, and I'm going to go through the existing project in order to see how we can do and how we are going to visualize everything under our structures. So here is my PROTA. I have already launched the PROTA, which is 2021. I'm using PROTA 2021, although I have the other versions. So, but based on this lecture, we are going to go to the 2021. The process is all the same with the other versions of PROTA 2016, 18, 19, and then 21 now. So what we are going to do, normally there are so many ways of assessing the undesign or the not valid, the design which are not valid of the structural member in the software. First of all, as you are seeing this member here, it is red. It means it is failed. Based on its design status, the member does not pass. Maybe it is maybe the deflection is not okay, or the reinforcement it is not okay on such a structural member. So what we can do first, we can go in order to see all the design of the structural members. What you will do, you can come into what after the analysis tab of the software, we have a tab called design. When you click, you will see story beams. There are story columns, story beam, rib beams, foundation, and so on. So when you click on the story beam, you will see all of the beams that the software undergoes the analysis and then the design of such structural member. So when you see this green mark, it means such member, it pass in what both deflection, shear, and it is not under reinforced or over reinforced on such the design load that it is subjected to such structural member. But when you see X here, it means that such member, maybe the thickness of the member, it is not enough to satisfy the deflection, or there is too much reinforcement, or the reinforcement that the software adopt for you, it does not reach the requirement that the structural member would be safe in both deflection and so on. So in order to recorrect such kind of issues, let us go to the first method where if you increase the thickness of the member, the software will notify you that the analysis will expire when you increase such thickness of the member. And then we will come back to the other method of increasing the thickness without the analysis being expired in the software. So what I will do, I will close this tab. This is the beam. You see it is red in color. Let us go into the 3D view of such a structure. This is the 3D view. It is a 3-story building. So when you check this structure, when you come into the global status, in order to view the global status, you come into review and then click what the design status. When you click, you will see red is failed, yellow warning, this color expired analysis, not okay, not the design, do not, and so on. So the first thing is that let us come back to the plan view. When we come to the plan view, in order to increase this thickness of the member, you can click on the beam, right click, go to the property of such structure, remember. When you come to the property, assume we want to increase the depth. When you increase the depth and then says update, the software will say the following analysis result will be invalidated if you proceed. And we don't want the analysis to be invalidated. So we want the analysis to be valid, but we want to increase such thickness of the member in order for the software to take it automatically, analyze the structure without notifying us it's analyze, distribute, and so on of the load. So now I will click on no. If I click on yes, it will increase the thickness of the structural member, and then the analysis will be invalidated. And if I click on no, it will not increase the thickness and the analysis will be valid. It will be still valid. Then I will click on no. Then the first method of increasing without the analysis being expired is click on the structure, remember, come back into what here. There is a tab called design section design. When you click on the section design, it say the design is not valid. Do you want to update the rebars? It will ask you automatically. When you say yes, it will go under so many analysis and what update the rebar of such structure, remember. But when you check here, you will see some red messages, some red issues where it is happening on the structure, remember, and you will see the shear reinforcement at the support and here also at the support, here at the middle of the span. Here it is as 1/3 of the support, here also at 1/3 of the support from right-hand side, here from left-hand side. You can also visualize the detailing of such structure, remember, from the detailing part of such a software. In order to visualize, this is the detailing. We have 3Y16 and 2Y12. You will see the detailing here also. So as a structural engineer, someone might say that he don't want too much confusion in the site or no too much argument with the client in order to say he will not provide 3Y16 here, 2Y12. Let us take it to 16 and then 5Y16 and 4Y16, almost to 10Y16 in one beam. So in order for you to minimize such kind of things, you will increase the thickness of the member in order to reduce the quantity of the reinforcement. How can we increase the thickness of the member? That is the first question. You can click on this one here and then increase the thickness from this position. That is the first place of that is the first method of increasing the thickness of the member. Or we can come into beams at the tab here, click on beam. When you click on beam, you can visualize the beam here. Here you can visualize, we can see the side view, the 3D view of such beam. So in order to increase the thickness, we will come back here and then take the beam to 500 and then click on enter. It will increase the thickness of the beam automatically. It increases the thickness of the beam. If you are seeing this blue highlighted span, let me reduce the thickness to 450. It will reduce in depth, enter. It will reduce in depth, but when you increase it to 500, it will increase in depth automatically. So we have increased this thickness of the member. Then we're supposed to see what reduction in the quantity of the reinforcement. When we come back to rebar, and we come back here, you will see the maximum area here. It is what, 622.34. That is almost greater than 3Y16. And here we have 5Y16. Then we can also reduce this number and then come back here. You see, if we say we reduce the normal, the bottom, we have two layers here. We remove the first layer and our 3Y16 is satisfied here. When you check, we have the area 592.35 millimeters square and 3Y16, it is 306 millimeter square. That is the area. And then you will see here also is 4Y16. Here is 504. 551, we can reduce the number of steel to be 3 and everything here as it is red. Now it is not red, but when you increase, you will see red messages. But when you leave it here, there is no red in your message. So you see from 10Y16, it has been converted to 6Y16. We increase the thickness in order to reduce the quantity of the reinforcement at that position. So many students or the participants were curious in order to know how we can visualize the moment on such structural member. You will see such the quantity or the area required on such midspan. Then how can we know the moments on such structural member? So what we are going to do, we will come back to this beam. Then you will double click on this place. When you double click, it will open a tab for you. When it's open a tab for you, it will notify you everything on such a structure. Remember, here you have the moment, which is 88.1 kilonewton meter. The moment here due to the support at each compression phase, that is 23.3, here 18.9, here at the midspan at the top, that is the compression is 0, at the support 82.5, at this support is 76.2. So if you like to edit everything manually, you will click here in order to reduce the moment based on your calculations. So many engineers, after doing the design in PROTA structure, they will say, let us check the design, or they will send it to another engineer who is better than them, or who is approximately the same with them. He might encounter something, or he might notice something in order for you to recorrect, and the structure will be much more stable. So you click here, edit, and then put everything that you want. The software will adapt automatically without the analysis being expired. But we are not going to edit everything. Just click on this box and we finish. Here it is the shear at both support. And then we'll click on OK. By visualizing the shear, you will see 109.7 kilonewton. And then at the left and at the right hand side is 106.8. You know that the shear at the left hand side will be greater than the shear at the right hand side. When you come back to the rebar, then we will click on OK here. When we come back to the rebar, you will notice the spacing of the shear links here. It is at 250 and here it is at 275, which notify you that the shear here is much more greater than the shear at this position. Then you can visualize the detailing of such beam in order to see how it arranged the bar for you at this place, and everything is okay here. Then you can go for the diagrams and also to see the shear force and bending moment diagram, which depend on the load cases. You can visualize the load cases here and everything for such a structural member. So this is the process that you will adopt for each and every kind of member. And if you don't want the analysis should expire, if I click on cancel, it will not update what I did recently. But if I click on OK, it will update everything, including the thickness of the beam on my structural drawing. When I click on OK, it will run. You see it is running, and you see the thickness is increased to 500 in this position. And when you visualize the structure in 3D, you will see such beam which failed. It is normal. Now it is satisfied at such position. So let us consider another beam. There is another beam here, which I noticed the quantity of the reinforcement, it is much more, but the thickness is satisfied, but the quantity is much. So when you click on this beam, which is 500, but the span is almost 6 point something meter, then come back to the section design. It will say bar do not fit in the cross section. I will say, okay. Then when you check here, we have 6Y16 at the compression phase, and at the tension, we have 4Y16. So in order to remove these error messages, come back to the beam here. Also, let me increase this one to 600. I'll click on enter, come back to the rebar. It decrease this quantity of reinforcement to 5. And then this one also, we have 6104. Then this one will be almost to 4 number of reinforcement. Since 603 it is 3 and here it is greater than 603, then you will visualize that such a red message also did not go. You can see, so let us go for an iteration in order for the structure to be safe. At that position, come back to rebar, and then here you can reduce it to 4. When you reduce it to 4, here you can reduce it to 2, and here increase it to 3 at that position. So you see, we reduce the quantity of the reinforcement much more, and then the red messages is there, but it is not an issue, but we don't want such in some kind of situation where the structure it is heavy loaded. So here also you can visualize the moment both at the midspan, at the support. Here is 109.8, 150, 145, and so on. You can click on OK automatically. When you click on OK, come back to rebar, visualize the detailing of such beam. You will see 3x16, 4x16, and then you will see the section of such beam. So some might ask why at the compression phase it's provide 4y16 and at tension is 3y16, where and such structural member it is singly reinforced. The reason is that it adopts the support reinforcement at the as the compression reinforcement in order for you to have so many cut lengths. That is, from this support, you will have 1/3 here, cut the reinforcement from here 1/3. The remaining place, it will not be up to 2 meters. Then it's much more easier just to put the support reinforcement at both the compression phase. So when you click on OK, it will update the thickness automatically to 650 as you are seeing here, and without the analysis being expired. So I think this is the end of our lecture. If you have any question, please you should ask. I have sent a message for you to the chat in order to fill the attendance form, please. In order to fill the attendance for much more anything, for much more clarification. And if there is any question, you can unmute yourself in order to ask a question, and I will answer such a question for you. Any question, you can unmute yourself, and if there is no any question, then we can call it a day. Or when you go to the lecture again, you can send your message or your question to our training group on WhatsApp. So any question? If there is any question, talk please.